I'm going to show you how to use the Excel Companion Significance Testing Workbook to generate confidence intervals for the difference between two sample proportions. If you're watching this video, I'm assuming you already understand a few essential concepts. I'm assuming that you know how to make comparisons with nominal and ordinal level data, also that you understand the foundations of inferential statistics, especially the concept of confidence intervals. This video is for people who already know what confidence intervals are and now want to learn how to generate them with Excel. It's easy to generate confidence intervals for the difference between two sample proportions with the Excel Companion's Significance Testing Workbook. You can download this workbook from the Excel Companion's website. You just input a few values specific to the problem you're trying to solve. The worksheet does the calculations and shows you the results. To generate a confidence interval for the difference between two sample proportions, you make three inputs into our worksheet. 1, the confidence level, 2, the sample proportions, and 3, the sample sizes. These values should be given in the problem you're working on. After you enter this information, the worksheet shows you the confidence interval on a graph, reports its lower and upper bounds, gives you the margin of error, and shows you how it calculated all of these values. To see how it's done, let's work through a couple of examples. This example reads, a college's annual survey asks students if they have done an internship. In 2019, 0.397 of students and 1,120 said they had. In 2023, 0.446 of students and 1,156 said they had. Generate a 95% confidence interval for the difference of proportions between these survey years. So it looks like the proportion of students doing an internship has gone up from 2019 to 2023, and we are going to generate a confidence interval of the difference between those sample proportions. So I'm looking at the significance testing workbook here. I'm going to click to the difference of two sample proportions page and our inputs. The problem tells us that we're dealing with a 95% confidence interval, so I will leave that as is. For the first sample, now the difference is going to be calculated as the proportion 1 minus proportion 2. I want to use 2023 as proportion 1, so the difference is a positive number. The proportion of internships has gone up. So I'm going to enter sample 1. The proportion is 0.446, and that sample, the 2023 sample, has an N of 1,156 students. Now, sample 2, the 2019 year, the proportion then was 0.397, and it had a sample size of 1,120 students. Done all my inputs. Now the worksheet shows graphically the confidence level, and it zoomed out quite a bit to go from -1 to +1, so it looks fairly narrow, but the cells here tell us that the point estimate is 0.049, roughly almost 5%. The lower bound is 0.008 and the upper bound is 0.090. So to generate the confidence interval, if I would report this confidence interval, I would say that the 95% confidence interval for the difference of proportions between these survey years is 0.008 at the lower bound and 0.090 at the upper bound. Another example of the difference of sample proportions. Example 2 here reads, a researcher examines the effect of a defendant showing remorse using randomized mock jury trials. 57.9% of 65 mock jurors would find a remorseful defendant guilty. 68.2% of 67 mock jurors would find a non-remorseful defendant guilty. Generate a 90% confidence interval for the difference of proportions to show the effect of remorse on finding guilt. So the remorseful defendant is found guilty 57.9% of the time, and the non-remorseful defendant is found guilty 68% 0.2% of the time. So the remorse, the effect, decreases the finding of guilty. So our confidence interval should center around a negative proportion this time. I mean, generally you want it's kind of easier to interpret if the effect is positive, but given the way the problem is written, to show the effect of remorse on finding guilt, it's going to have to be a negative number. Okay, so I'm looking at the confidence interval of the difference of two sample proportions worksheet. My inputs start with the confidence level. The problem asks for a 90% confidence level, so I will click it down to 90%. Like I kind of talked about in the discussing the prompt. The first sample, 1, remember, proportion 1 is proportion 1 minus proportion 2 is the difference. So the proportion 1 should be the remorseful defendant. The problem gives us a percentage, so I'm just going to move the decimal point over to input. This is a proportion 579. Smaller sample this time. This sample is based on 65 mock jurors. The second sample, the non-remorseful defendant, is found guilty 0.682 of the time with a sample of 67 mock jurors. Okay, so let's look at our plotted results here of the confidence level. The point estimate is a decrease in the probability of guilt by 0.103. The lower bound of the estimate is negative 0.240, and the upper bound of the estimate is 0.034. So to report this confidence interval, I would say the 90% confidence interval of the difference of proportions has a lower bound of minus 0.24 and an upper bound of 0.034. The possible values would be anything within that range with 90% confidence.